Hi everybody, this video is our first lesson in thermochemistry, which is chapter 17 in your textbook. This image, which starts off your chapter, is an image of a solar furnace. Uh, and a similar idea to a solar furnace is a solar thermal power plant. I'd love for you to take a moment to check them out using the link that's in the presentation that goes along with this video. So here's a picture of a banana split. We don't think about ice cream as being a hot food, but it does contain heat. I'd like for you to think of the ways that ice cream could contain heat as we go through this lesson. So a broad key question for this unit is about energy transformations and which ways that energy changes can occur. Some more specific concepts that we'll be learning in the entire unit, not just this lesson, is about the idea of energy versus matter, potential versus kinetic energy, the idea of heat being thermal energy that can be transferred, and the laws of thermodynamics. The other points here we will be getting to in later lessons. So energy is defined as the capacity for doing work or supplying heat. It doesn't have mass or volume, so it's not matter. This is something that can confuse students quite frequently. And you wouldn't think it, but saying something like, I got a lot of energy in that hamburger or something like that. You have to be careful with how you think about that concept. Energy is only detected because of its effects. There's a link to a video here that talks about the fact that since energy is hard to define as an actual thing, it's easy to think about it not being real. It is detectable when something happens. Thermochemistry is a study of energy changes that occur during chemical reactions and also in changes of state, although we may or may not be able to get to state changes during this unit. So just as a reminder, let's remember that most energy is either thought of as being potential or kinetic energy. So potential energy is the energy that could be used for doing something, whereas kinetic energy is the energy of actual motion. This is showing an object changing its potential energy to kinetic energy and vice versa. So every substance has a certain amount of energy stored in it. The energy stored in chemical bonds of a substance is called its chemical potential energy. Chemical potential energy varies based on the kinds of elements that are in the substance and the way that the atoms of a substance are arranged. As an example, carbon-hydrogen bonds are thought of as being fairly high energy, and this relates to a lot of concepts that you will learn about both this year and next year, such as the idea of hydrocarbons and even things like fats, which have a lot of carbon and hydrogen bonds and also a lot of energy. To further that idea, when you buy gasoline for your car, you're really buying the chemical potential energy in the gasoline. There's a lot of energy that can be released from gasoline, and when that happens, you can convert the chemical potential energy to kinetic energy that drives your car. You also produce a lot of heat. So energy changes occur as either heat transfer or work, or as a combination of both. I've linked in the presentation a brief video that goes about the interconversion between potential kinetic energy and heat that are involved in a car crash. Heat is in calculations is listed by the variable lowercase q, and it's energy that transfers from one object to another because of a temperature difference. Heat will flow from an object that has a higher temperature to an object that has a lower temperature. If you keep two objects together long enough, their temperatures will eventually reach the same point. So pause it, think about the video, think about this question, and see if you can come up with the right answer. Right? The answer is chemical potential energy. When you burn wood, you are releasing the energy that has been stored in the bonds that make up the chemicals of the wood. So we're now going to get into the idea of endothermic and exothermic processes. And this key question is really sort of an intro into one of our first laws of thermodynamics. The idea of what happens to the energy of the universe. Endothermic and exothermic refer to whether heat is being released or absorbed. Before we get into this much further, we need to talk about two terms which can be a little bit confusing. It's the idea of system and surroundings. So the system in this discussion is going to be anything that you are interested in or are studying. The surroundings is anything else that's in contact with the system that isn't what you are studying directly. You can think of the system plus the surroundings as being the universe. I know that's kind of weird, but that's the way that the study of this works. So here's sort of an image to think about it. If we're studying the green goo in this flask, then the green goo is the system, the flask that it's in, the thermometer that's stuck in the flask, the stand that it's on, the air around it, everything else is the rest of the universe. So the system plus the surroundings are the universe. So let's get to our first law of thermodynamics. This is the law of conservation of energy. And it states that in any chemical or physical process, you can think of this as a chemical reaction or physical change, energy is neither created nor destroyed. So this sounds very much like the law of conservation of matter. In a chemical reaction or whatever, law is neither created nor destroyed. And this means that during either of these kinds of processes, physical or chemical changes, the total amount of energy that you're starting with is going to be the same as the energy that you end up with. Whether or not you can actually capture all of that energy is another question. Many times during a change, energy is going to be lost, usually as heat. Another way to think about the first law is that during any chemical or physical process or change, the energy of the entire universe does not change. So if the energy of the system increases during the process, the energy of the surroundings must then decrease because the total energy of the surroundings in the system must be the same. If the energy of the system decreases, then that means energy must have been lost by the system and have gone to the surrounding. So when we talk about the direction of heat flow, we're almost always going to be talking about it from the point of view of the system. If the system absorbs energy from the surroundings, that means energy is going into it. The prefix for that is endo, so this is an endothermic process. Heat is going into the system. We talk about heat flow going into a system having a positive value. So if heat is going into something, then the heat value, the number, will be positive. If heat is going out of the system into the surroundings, it's exothermic, exo meaning outside. When this happens, we think of the heat value having being negative. So heat being lost is negative. Here's a way to think about these two processes. In both these cases, the system are the people in the photographs. The one on the left is showing somebody relaxing by a fire and being warmed up by it. So heat from the fire is flowing into the person. This is an endothermic change. On the right side, we have someone who's just been working out and is releasing heat out of himself into the surrounding air. So that's an exothermic process. So how does this ice cream contain heat? Well, there's two different ways. First off, there are lots of different compounds in this dessert that contain chemical potential energy, which can be converted to heat. We'll learn more about that. Also, even though we think of this as being cold, cold is a relative term. If we put this banana split into a freezer where the temperature of the surrounding air was cooler than the ice cream, heat would still be there and would be flowing out of the ice cream into the surrounding air, and the ice cream would get even colder. So that's going to be the end of my screencast for this lesson. There are two more points. One is a thought question about endothermic and exothermic processes. So feel free to work through that in the presentation that I've shared with you. There's also a discussion of specific heat, which we may get to and talk more about in a further lesson. All right, I hope that this helped. Thank you for your time.